Now, of course, we all know this. Scientists cannot resist a calculation. The idea of a calculation is to find the frequency that the listener hears the sound at, compared to the original frequency of the source.
The symbols we will use in the calculation are as follows. There will always be a source of the sound. This is the object making the sound, for example, the bike or the ambulance. Then there is also always a listener. This is the person hearing the sound. I trust you know the symbol for velocity. When we add the subscript s to velocity, it means the velocity of the source. Adding the subscript L to velocity refers to the velocity of the listener. Then there is a symbol for frequency. When we add the subscript s to frequency, it means the frequency of the source. Adding the subscript L to frequency refers to the frequency at which the listener hears the sound.
Now, let's look at the equation. Looks complicated, doesn't it? Let's make it easier. You will see that the whole point is to find the frequency at which the listener hears the sound. The v without the subscript refers to the speed of sound. This will probably be given to you, but if not, you can use 330 meters per second. VL and VS refer to the velocities of the listener and the source, as we have already said. And finally, Fs refers to the frequency of the source of the sound. The tricky thing is to know when to use those minuses and pluses. Here's one way that can make it easier. First, write down VL and VS. Always VL first and then VS. There will always be one of them that is stationary. That is, the velocity is 0, and the other relative to this one. Write a 0 above the one that is stationary, then draw an arrow above the other one, showing whether it is moving away from or towards the stationary one. For example, if the listener is stationary and the source is moving towards him, then VL is 0 and the arrow above the source is to the left. Use the convention that left to right is positive and right to left is negative. In this case, you would give the velocity of the source a negative sign.
So let's look at an example which you'll find on your worksheet. A car is driving at 100 kilometers per hour with its hooter constantly on. It drives past a boy standing on the side of the road. If the hooter has a frequency of 10,000 hertz, with what frequency will the boy hear the hooter while the car is moving towards him? Now, the first thing you need to do is convert the velocity of the car to meters per second. Convert the kilometers to meters by multiplying by 1,000, and convert the hours to seconds by multiplying by 60 minutes per hour and again by 60 seconds per minute. The answer is 27,8 meters per second. Check your signs. The listener is stationary and the source is moving towards him at 27,8 meters per second. That means VL is 0 and Vs is negative because it's moving towards the left. Now substitute into the equation. V is equal to 330, VL is 0, V is again 330, and the velocity of the source minus 27,8. The answer is 10,900 hertz.
Now ask yourself, does my answer make sense? The source is moving towards the listener, so the pitch is higher. That is, the frequency must be higher. 10,900 is higher than 10,000. Yes, this makes sense.
Now what if the car was moving away from the boy at the same speed? Your signs would look like this, and your calculation like this. The speed of sound is still 330, the velocity of the listener is still 0, but the velocity of the source is now positive 27,8. The answer comes to 9,200 hertz.